Hello and welcome to this lesson about system of equations word problems. The learning target for this video is setting up and solving system of equations from word problems here. So let's talk about the process. First of all, the big thing you have to do when dealing with system of equation word problems is set up the system. And a large chunk of that is making sure that we sort of label the variables. We know what we're wanting x and y to be. That's huge for setting up the system. After that, the next step is solving the system. And I'm going to kind of expand on this and say solving by using the quote-unquote best method. And what I mean by best is like whatever one the system is sort of predisposed for. Some systems are great for elimination, some are great for substitution. With word problems, you're not going to be confined to a box and try to solve it and be told, first of all, set up the, the system and then solve it using substitution. You can use whatever method you want. So use the one that makes the most sense. And finally, this is huge, answer the question that's asked. So the big difference between a word problem and just a given system of equations that you need to solve is that there's a question you might have to ask. You might only need to solve for x or y, not both of them, and you might have to be able to apply it. So just make sure you answer the question that's being asked of you. Excuse me. All right, now let's talk about the different types of systems of equations, because that's huge for when it comes to solving them. The first type kind of follows this format here, where we have x plus y equals a number, and then we have ax plus by equals another number. Now the thing is, these equations are representing different units. And so my classic example for this is a basketball game. All right, where you've maybe made 7 shots. And so the idea is that the x and the y represents, let's go with 2-point shots and 3-point shots. And then the coefficient for a and b would be 2 and 3. For each 2-point shot you made, you got 2 points. For each 3-point shot you made, you got 3 points. And from this, you have a total number of points. And so let's just say you ended up scoring 14 points. Not quite sure if that's possible. I'm just making this up as I go. But the point with this is that we have different units here. All right, and so that's one type you're going to get. The second type of system of equation you're going to get is something that looks like this. Ax plus by equals c. And then you'll have dx plus ey equals f. And what this is the same unit. And so where we tend to see this one pop up a lot is maybe like if you go to a game, a concert, a play or something like that, and you have something like adult tickets versus kid tickets, and how they cost a different amount of money. And so it might be like on one night, so many adult tickets were bought, so many children's tickets were bought, and this is how much money they made overall. On a second night, same thing, but now a different amount of money. Use that information to find out how much the adult or the kid ticket costs. So that's another variation or type of system you might get. The third type is where you might have ax plus by equals c, and then you're going to be given a y equals situation. So keep in mind, that's fair game to where you have y equals something. And then the fourth and final type, well actually fourth, not necessarily final, is you might be given 2y equals situation. And so this one's often used in sort of maybe like a cost comparing situation. So cost comparing, where y is your total cost, and then you're given some information about how that number is given or found. The final version, which I'm not going to write, is thinking on your feet. So these are word problems. They don't always follow some sort of formula or pattern, and so you may have to think on your feet and cook up your own system. But it helps to have these in your back pocket as we approach some systems here. So I'm not actually going to go all the way through and solve the systems. I'm more just going to show you how to set them up, because that's what it boils down to. And also, at this point in time, you should be able to solve a system. All right, so let's look at number one. A woman's age is 3 years more than twice her son's age. The sum of their ages is 84. How old is the son? So, again, X and Y really helps to sort of set them up to figure out what are they going to represent. So let's just say the X is the son and Y would be his mom. Now what we're told is that the sum of their age is 84. So we take X plus Y and we're going to set that equal to 84. Now I have to look at the other information I'm given here. The mom, or the woman, her age is 3 years more than twice her son's age. So that looks like an expression. The woman's age, so remember, mom or the woman, is equal to Y, or is Y. That equals 3 more than twice her son's age. So 2x plus 3. And here I have a system. This is what you need to do. You need to set it up. Now it's about solving. And for me, I would look at this and I'm thinking substitution for my method of solving. And then once you solve, you have to make sure that you've answered the question here. Unfortunately, if I were to put this into substitution, I would get x equals some number, and x represents the son, so I would be answering the question by finding out what x equals. Again, I'm not going to do that right now. I'm focusing more on how to set them up. So let's take a look at the next example. Oops, not what I wanted to do. Let's try this. There we go. All right. A plumber, work with me. There we go. All right, a plumber charges an initial amount to make a house call, plus an hourly amount, or an hourly rate for the time he is working. A 1-hour job costs $90, and a 3-hour job costs $210. What is the initial amount and the hourly rate that the plumber charges? All right, so when I'm reading this, what I'm thinking is this represents to me like a AX plus BY equals something and a CX plus DY equals something situation here. So I know that and so again, it helps to identify the variables. Let's say that X is just sort of the initial, or like, where is it? Initial amount. So I'll rewrite that IA. And Y is the hourly rate, HR. So if I have X and X, like that's going to both be the same there. So X is going to be 1, or the coefficient is going to be 1, plus, and then for a job that was 1 hour, so 1Y, that cost $90. The 3-hour job, so that's going to be plus 3Y, cost $210. I've now set up a system, and this system to me is looking like maybe a great candidate for elimination. Elimination, where I would just end up subtracting this one right here, so I'd go minus x minus y equals negative 90, and then I would combine these two equations to cancel out the x's and solve for y. Now this one I do need to solve for both x and y because the question is asking me for both of them. But another question that could be added on is it could be said, hey, find the initial rate or find the initial charge and the hourly rate and how much it would cost for like a 6-hour job or something like that. So again, there could be an added on question that you do need to solve. All right, 2 more. So this one, a man and his 3 children spent $40 to attend a show. A second family of 3 children and their 2 parents spent $53 for the same show. How much does a child's ticket cost? All right, so again, let's identify maybe what X and Y will be. The 2 things I'm seeing here is an adult, so a man, parents, and I'm seeing children. So let's just say X is the adult and Y is kids. So X plus Y is equal to 40. However, how many adult tickets were being bought? 1 adult ticket and 3 children tickets. For the second family, we have 2 adults plus, 3 children as well. 3y equals 53. We've now set up the system, and again for this one, I'm thinking elimination. Elimination would be a good method for this one. You could also do substitution if you just bump over the 3y that way. And here, answering the question, how much does a child's ticket cost? You need to solve for y in that one. All right, and then final one. Click that. Oops. Try that again. There we go. All right. A large pizza at Polonzio's Pizzeria costs $6.80 plus 90 cents for each topping. The cost for a large cheese pizza at Guido's Pizza is $7.30 plus 65 cents per topping for each topping. How many toppings need to be added to a large cheese pizza in order for the pizzas to cost the same, not including tax? All right. So what I'm seeing here is a y equals situation. All right. So at the first pizzeria, it is y equals the initial cost, $6.80. That's how much it costs for you to have a pizza, plus however much you're spending or however many toppings you get. So that'd be 0.90x. Second pizzeria is $7.30 plus 0.65x, so 65 cents per topping. And then it's asking me to find, how many toppings need to be added so that way the cost is the same. So what toppings represent, that's x, I need to solve for x. And here we have a couple of options. You could use the graphing method, which would work out pretty well. You could also use substitution. So graphing or substitution are good methods for that one. So that's how we go about dealing with word problems. Again, just to kind of go over the process, it's all about setting up the system. And what really, really helps is figuring out what x and y represent. After that, you solve. I didn't show any of that, but by using the quote-unquote best method there is, the more efficient method. And then finally, make sure you are answering the question that's being asked. That's how word problems differ from regular system of equation problems. So good luck with your homework or practice, and let me know if you have any questions.